My name is Michael Oros. I'm the Executive Director for SNIA. Alex McDonald, who was on the agenda to present this, unfortunately fell ill and was unable to travel to Israel this week. He sends his regards and is already conveyed that he misses the food and the beer and all the fun hallway tracks that occur at this event. So, without further ado, today, wanted to get into really kick it off first with on PMEM. First of all, have to understand, it is a programming model that SNIA works on, but software doesn't run on thin air. It runs on hardware. So I wanted to just quickly cover the persistent memory hardware that's available, underline, highlight, however you want it, available today. It's been available, so I want to make sure that you understand we're not talking about futures here, but things that you can actually go buy, touch today, and go deploy. Then kind of a quick summary on the programming model itself. What everyone should know about PMEM, the things that most people forget, some of the ways that you can use PMEM with no changes to your applications, no modifications. We spent a lot of time talking about how you modify your applications. What do you need to do to take advantage of persistent memory at the application layer? But guess what? There's so many benefits that a current application can get out of persistent memory with zero changes whatsoever to that application. So I want to talk about those a bit. Touch a little bit on some of the modifications that we've seen out there, what are some of the learnings, some of the libraries that are available, and kind of in general the learning so far and where we're headed. So, ready? Strap on, roller coaster ride for the next 30 minutes. So, fundamentals, whenever you make a substantive change to your compute architecture, bringing new technology in, such as persistent memory, it requires an ecosystem. This isn't done by a single company, this isn't done by a single organization, and this isn't done at just one layer, done, call it good, and forget about it. No, this requires, from the hardware perspective, standards that help drive interoperability of that hardware when it's actually deployed, the software component that then takes advantage of that hardware and standards that are then deployed on platforms, the software that helps take advantage of that. Highlighted some of the industry ecosystem players that have been working hard at this, not just in SNIA. SNIA works with other standard bodies like JEDEC. We don't like duplicating efforts. So JEDEC is great at doing memory, doing DIMMs. We work with them on the persistent memory aspects of it, threat models, et cetera, et cetera, et cetera. So within JEDEC itself, what it defines, NVDIMM-Ns, NVDIMM-Ps are two of the popular NVDIMM types today. They have their own advantages, disadvantages. I won't be able to go into details, but all of that is available on the SNIA website in glory detail. Again, highlighting, this is available now, NVDIMM-Ns. NVDIMM-Ps are still in definition mode. They're finishing the 1.0 spec around this. They're looking at a lot of the consideration of protocols and latencies, because some of the media that would go into NVDIMM-Ps potentially have higher latency. So how do you handle that? How do you deal with that? Again, there's certain applications that care more about capacity than latency, and that is perfectly acceptable for those use cases. Some highlight of the target applications of NVDIMMs today. Again, sorry, on the previous slide, really quick, way earlier slide, you saw that hardware, lower left corner over there, Gigatech, Micron, SK Hynix, Smart, Modular, Viking, Enlist. Those are the companies that have NVDIMM-Ns in production today available for you to purchase. There's equal number of platforms out there from OEMs that their platforms are aware of this. We've done demos at events throughout the industry where we've populated our platforms with a NVDIMM-N from each of these companies and showed the functionality on that platform, demonstrating the interoperability of the ecosystem that's worked very hard to enable this. and get us to the next step where we can actually get the applications to take advantage of these capabilities. And of course, it really prepped and primed the road for what's coming now this year to full market and availability is persistent memory media. There's new media in addition to DRAM battery or capacitor backed persistent memory DIMMs. There's now persistent media itself that is augmenting the storage tiers and the performance benefits we've all come to love from things like from flash technologies. But now we have new medias that will bring even more diversity and options to our architectures and hierarchies and solutions. So this is a list of some of the target application areas. Obviously, some applications get more benefit than others from persistent memory. Databases are an obvious one, the minimum some of the transaction logs around databases to accelerate those. For storage in general, making your file systems PMAM aware. For virtualization, big data, one of the other big places for AI and ML, it really helps to provide better modeling and operation of those systems when you can actually have your data set, both for training and for operational, to essentially have it be in memory. So that's the hardware piece. So whenever, again, as I mentioned, whenever we talk about persistent memory, stop and ask yourself the question, am I talking about persistent memory as the hardware itself, the media, or are we talking about the persistent memory as in the programming model, the stacks, and application access to persistent memory? So I'm going to switch gears now onto that, into the programming model itself. But in general, right, on persistent memory, if you think about persistent memory, what is it? It essentially allows load store access. It's like it acts and behaves like memory. It's persistent like storage, so that's the differentiation factor there. And it's exposed to applications using the SNIA NVDIMM programming model. One of the things the group did when it formed was to come to agreement on terms. So SNIA also publishes this SNIA dictionary available for you to grab one out there if you enjoy still touching physical things, like a paper dictionary available online as well. But the group got together to define, okay, what actually is or would be persistent memory? And part of that definition, essentially, that Twig said would essentially, it's not persistent memory if it would reasonably stall the CPU while it's waiting to load, for load to complete. So obviously, from another perspective, if it's doing blocks like in a disk, SSD, flash, then it's not considered persistent memory because, again, you're not doing load store. So the programming model itself covers a few different use cases here, right? Of course, you have the management interface for accessing and managing persistent memory. You can access it as storage, you can access it as file, or you can access it as memory. So it's common, and again, we especially from developer perspective, to just forget the fact that you can just use persistent memory as disk. You can just present it to your application as disk. Just during your config, you're pointing to persistent memory now, but from an application's point of view, it's just a really fast disk. And it's actual storage because it's persistent. It's not just a RAM disk. So again, want to make sure people don't forget about that. If analogy is, think about the days when everyone got their hands on their first SATA flash drive for their laptop, right? All of a sudden their laptop was just flying, was actually usable. You got excited to actually open your laptop because it was responsive. You had huge performance improvement, but you're still using this new technology, the flash, in the old form factor, still a SATA interface, but you got the huge performance boost to your laptop, just swapping out a piece of hardware. And that was great, but you weren't taking full advantage of the performance of the media that had capable until we evolved to the next stage with NAND, with flash, and we went to NVM Express. You were able to change form factors then, being able to have much thinner implementations of the drive, a faster interface on PCI Express, all enabling, again, the different form factors. Then you got an even higher performance improvement to your application from a user perspective. So the same thing with persistent memory. Kind of using it as a disk, it's just think of it that equivalent of you just swapped out your old spinning SATA drive in your laptop with an NVMe drive. Instant performance benefit. From a file perspective, right? You can have the file access. This essentially, from an OS perspective, Windows Server 2016 supported as inbox, DAX access, direct access. So essentially, in this case, you have a file system that's persistent memory aware. You can just do your normal file operations in this case, and you're getting the benefit. These are all standard. There's no changes up to this point on how you're accessing your data. You're still using the old standards. One other use case to just highlight is some of these new persistent memory technologies that are coming in form of DIMMs, and there's 2 of them out there in production this year that are 2 different technologies available. Some of them provide for just higher capacity than DRAM or NVDIMMs, which are DRAM based. You can still use those persistent memory DIMMs as just volatile capacity. Effectively, you're using your DRAM as your cache, and because you're doing that, it's a volatile use case, because if your system goes down, you lost your cache, even though your persistent memory is there. But you just increase your capacity a tremendous amount for, again, certain applications. So just highlighting, make sure we don't forget about those. So this is just quick summary, more useful if you're viewing this presentation later at a later time. I've already covered these verbally as we went through the earlier model. So you're saying, okay, so what's the big change with persistent memory? Well, it's this. It's what's called optimized flush. When you're able to go from user space and do the application directly do a flush to the memory. You're bypassing at that point everything else that we just talked about, and now the complexities come into play because your application needs to be aware to manage essentially your persistent memory directly. Don't panic, there is some good news. While you look at this chart, all the different ways that your application would need to be modified or could be modified to take advantage of persistent memory, the good news here is there are a bunch of different libraries that SNIA together with the industry has worked on that are available for you to use. Feel free to just literally copy paste, include in your application, or just rely on these libraries to use them. So you don't have to deal with the lower level aspects of the programming model, and you can deal with the higher level aspects within your application itself. All these resources and more available on the SNIA website. Just wanted to give you a quick highlight. So this is an example where this is a high level modification that's done. It's still experimental, not in production currently, but available, where enable a key value store. At a library level, already most of the hard work's been done for you. You can just go take advantage, play around with it, and use it as general purpose key value store today. That's PM aware and enabled, and it'll have the performance advantages of utilizing those new capabilities in the platform. Here's Another example, when you look at the kind of the full stack here in this scenario, right? Bottom, you've got PM-aware file system, the libraries, PMDK on top of that. And in this case, we're looking at Cassandra. So if you look at Cassandra as an application, then yes, you've gone in and modified Cassandra. But if you look at Cassandra as a middle layer, an API, that you've now gone and modified and made a PM-aware, bringing the performance of those capabilities up the stack, the applications that sit on top that take advantage of Cassandra, completely unaware that you've done anything, but they will perform much faster because they're sitting on essentially a PMM-aware and enabled Cassandra implementation. So you have to think about where your application really sits in the stack, and you may be able to get most, if not all, of the benefits that your application would get from persistent memory without you actually modifying it. So you just have to look and make those choices and decisions at the platform level when you're buying that platform to have these capabilities, and then a few of the middle layers in the stacks. So kind of quick summary of the learnings that we've had so far is, and you've heard me talk about some of these, is lots of ways to use persistent memory without any application modifications. If you are looking to go beyond that and start playing this, is first try using some of the existing APIs that are PMM aware. Try using some of the higher level abstractions before you really go and roll up your sleeves and get dirty with PMM and start really doing the raw map accesses yourself for your application, which is the advanced course. Good resources again in SNIA to help you with that as well. We've done a lot of different webcasts on this topic and a lot of white papers and documentation of the spec itself. So a little bit of where we're headed as an organization, industry in this space is really try to look at more of the transparent use cases that we could have. More higher level abstractions, so again, bring the functionality and performance without the headaches of the middle and lower libraries, and more support for experts as well. So this isn't done. There's a lot of innovation that is yet to be done, and all those models that I've just shown, that's a one system model, right? There's still the use cases for remote persistent memory. And what are actually the use cases associated with remote persistent memory when you enable that? Are you doing it for reliability? Are you doing it for other system design considerations? There's a lot of different use cases associated with that. And there's work to be done on how do we make that more performant. So a little bit more on remote persistent memory. In this particular area, SNIA has a strategic alliance in place with the Open Fabrics Alliance. For those of you not familiar with OFA, they essentially look at promoting and accelerating deployments and performance around fabrics. So a couple of considerations here, right? There are some challenges with the remote persistent memory, but it is usable. Some of the obvious things, it's NUMA by definition when you go remote persistent memory. It will generally require asynchronous operations, and the obvious part, you're going over networks, so there's some additional latencies involved. It all depends on the type of network that you choose to use for your implementation. So net, there's some challenges, but this is doable and expecting quite a bit of innovation in this space. You want to learn more about some of the use cases that SNIA and OFA have already started to document and enable the industry to work around those. There's a presentation from Paul Green on the Persistent Memory Summit page, which is a resource a link that I've included at the end of this presentation. Yes, please.
So you basically mean for the remote memory, basically it's RDMA to NVDIMM over some fabric like a Finland or HMI.
Correct.
Start with that. So my question is here that the persistency part of it, so you push the data over the fabric, it goes to the adapter, RNIC basically, and then it has to be pushed to the system memory remotely. So it have to be changes inside in the industry to support that.
Absolutely. That's and that is why we're working with OFA. Correct. Yeah. There's absolutely changes that need to be made there, and some of the changes, again, there is room for performance improvement on how you do that in the long term as well. In the initial, let's just get it done, make it work, and then there's opportunities for how you do it more efficiently in the future.
Do you see public cloud providers supporting or supplying persistent memory anytime in the near future?
Absolutely, and you just jumped ahead a few slides on me with that question. We just had a hackathon last week. Google sponsored it, where we essentially had about 30 developers on site at the SNIA Annual Member Symposium Conference in Santa Clara, playing around essentially how do you do the persistent memory programming model, how do you take advantage of that in cloud implementations. I won't speak to Google's timeline for offering those services publicly, but that was the hackathon developer session that we did, and we're planning to have some more later this year as well. So short answer, yes. Absolutely expecting persistent memory in clouds, in public clouds, to be available.
But it will probably be accessed over the net, right?
Correct. Yeah. Well, again, some of it you're accessing over the net, but in the cases where you're running your app in the cloud, it's being able to take advantage of persistent memory there locally, right? That's the most palatable use case where you're getting the performance advantage. Otherwise, you're dealing with the latency of going over the network to the cloud.
But that will block workload migration and stuff like that.
I'm sorry, I didn't catch the first point.
That will anchor your workload to a specific physical server.
Again, it depends how you're looking to use persistent memory, but you typically want to use persistent memory because of for performance reasons. So.
Yeah, but then again, it's physical, right? It's physical component.
Yes.
The block within offers, right, is usually a SAN. Right, so the VM can just shut down and respawn in another machine, which is memory. We need to work the same concept.
Yeah, absolutely. I mean, and again, if you look at, the industry has also done work to where, as you pointed out, within a VM type implementation, shared model, you're actually able to assign now persistent memory directly to a VM within those instances. So.
To several VMs. Right.
Correct, yes, not just one. So a quick look at Java and persistent memory, right? Why Java, you ask? There's a lot of very popular, I mean, it's a popular language on servers, and there's a bunch of the Apache projects, some of which are listed here, that are storage related and are the obvious targets that they would benefit from persistent memory in terms of performance. So I mentioned Cassandra earlier, so just wanted to explore a little bit more on how you would look to modify Cassandra, for example, and potentially bring some simplifications or additional performance to it. Right, so this is just to kind of level set a little bit on. This is a typical Cassandra write path, right? The way Cassandra itself works on the data on the DRAM side. It'll do its commit log, shove the stuff over to the mem table. Eventually, once that fills, it'll commit it down to storage, and then move on, continue its operations. Well, what if you would just change that from this configuration of the two-tier DRAM disk to persistent memory? It could possibly look like this, right? Where you're just going directly, you don't have to do the commit logs and the map table, because the stored, your disk tier, is getting replaced by persistent memory. So it's by nature persistent as you're operating. From a read path perspective, again, this is the read path in a DRAM disk combination. If you're moving over to persistent memory, this could be simplified tremendously. Don't know exactly what the performance overall would be. Obviously, it depends on some of the characteristics of the persistent memory media that's being used, etc. But in some of the use cases, the capacity is large enough to where you could just use persistent memory as an alternative or replacement for the disk. These are some resources. So this is an actual. There's work been done on this in the industry. Noted the resources in the storage engine stack that's noted here. The color-coded boxes here is where modifications have been made, right? And the associated resources where you can go grab them and play around with and see what performance and benefits you get in your particular use case. So, if you wanted to learn more about persistent memory, SNIA has, again, the PMEM programming model, a lot of white papers and resources, webcasts that we've done over the past 7 years on this topic. Available on SNIA.org/PM, trying to make it easy for you guys to find it. Also, I mentioned we do an annual Persistent Memory Summit. Just happened last week. A lot of really fresh, timely content there. Again, I've tried to summarize, give you a flavor of what was discussed and covered in that full day event. The presentations are already uploaded for that event and available there for you with the full agenda of that day. And the video recordings of that, again, should be up in the next week or so. Already covered a little bit the hackathons. Again, Google was a sponsor of the first hackathon we did. We're working with other public cloud providers and vendors to participate in the future hackathons. So we expect additional things. We'll let those vendors do their own announcement about when those services are available for public consumptions, etc. But the answer is yes, they will be PMEM-enabled public cloud services, and your ability to start playing with that, learn how to get your applications to take advantage of it, and learn about the considerations of it. The time for that is now. Our next hackathon right now is planned for March. For dates, location, information on that, please look it up on the SNIA website. We'll be announcing those as soon as we settle the arrangements for it. And we also are taking a goal and objective to make those available online, on demand. It's the beauty of cloud, right? You don't actually need an event, a physical event, to be able to go take advantage of this. Once we've done a couple, we've learned how to best present it and make it consumable for someone. We're going to put those online, and we're going to look at both the cloud providers and potentially setting up a stack with a diverse set of hardware capabilities in a SNIA. In the SNIA lab, Colorado Springs is where we have our facility. We mostly do PlugFest and other compliance work there. But we're literally looking at that, the cost, resources to stand up a couple implementations, make those available remotely for people to play around with. Again, experiment with different vendors, different technologies at their leisure, in addition to the public cloud providers. So that's all I had for today. Thank you.